Okay, hello everybody. Welcome to my talk about Sumo Logic notebooks. My name is Armin. I'm a data scientist here at Sumo. And what actually is my daily job here is I solve problems. And as a data scientist, I solve problems using data. So we are developing data-driven solutions internally and externally. And to be honest, it's not easy. Sometimes things go wrong. And sometimes stuff breaks. This can be, for example, the software is broken, it's brittle. It can be I have the wrong data for this problem. The data can't answer the problem that I'm asking the data. It can be that I don't know something. It also can be that I know something and I'm actually wrong. So this is why I feel that notebooks are important, because notebooks are about communication. So data science is not something a data scientist does alone in his chamber. It's a team sport. Data science is a team sport. And as such, we need a tool to communicate, a tool to learn together. And we, at Sumo, we use notebooks a lot for solving our data science problems. And this is an initiative, an effort to share our internal infrastructure with everybody, with our community, that you can do the same kind of data science that we are doing inside Sumo, also in your organizations. And as a tool or as a package, this is the Sumo Notebooks package. It's delivered as a Docker container, and in this talk I want to walk you through how it is built and give you an example of what to do with that. At the completion of the session, I hope that you will have three key takeaways. So you will know how to develop a data science workflow using the notebooks. You will be ready to run it on your laptop, and I already give you some pointers. This is like the link to the Docker Hub page, where you can actually download or using Docker to pull the container on your laptop, on your cloud infrastructure. I laid out a couple of those. Feel free to take them. We got lots more at the experts bar, and I also put them somewhere on the wall, so you might find the links everywhere. Okay, and finally the third takeaway is, you can use either Scala or Python to actually develop. So the tool that we are using is kind of multilingual, so it doesn't depend so much on knowing one programming language, but you can use more than one. This whole effort ties into our overall strategy. So as you have maybe heard from Ramin this morning, this is organized in 4 tiers. We have the operational analytics, which helps you on your daily tasks to debug and monitor your systems. We got the security analytics for actually getting to the attacks on your system and finding out who's attacking you, when, how, and actually helping you to defend against these attacks. And a new component that we're having is the business analytics, as we found out that many of our users are actually not only using us for the infrastructure tasks, but also for getting core insights into their business, what's the KPIs that are important to how to run the business. And the fourth pillar in this vision is this global intelligence, and this is where our team works. We are developing the solutions. So maybe you have seen the other talks from Bruno and from David on the main stage about the benchmarking and the global insights. This fits there. We use notebooks to actually develop these benchmarks. Oh, sorry. Push the wrong button. Let me try that one. Okay. Okay, so again, everything revolves around the Sumo core experience. And these are the four pillars. So the goals here is for the Sumo notebooks is that to enable engineers and data science people to leverage Sumo's data inside a machine learning framework in a way that data science like to do it, which is notebooks. Why this is the case, I will explain later. We want to empower you users to build the custom models and integrate with data wrangling, model management, and visualization tools and services. So this component of the visualization of the data, this is one of the core aspects of data science. This is different to developing regular computer programs where the visuals don't play such a big role. But for data science, it's very important because data is big, and you need kind of images to actually get the information in a short to get the information in your yeah, so that your mind can make use of the information there. Okay. Okay, so notebooks are kind of not only a local thing to data science. They have been awarded 2017 with the ACM System Award. This puts them into a line with things like LaTeX and this kind of stuff. So it's really a huge movement behind this notebook. So in the ACM honored the Jupyter project. Also Gartner has picked up on them and put them on their kind of hype cycle. So if you believe it or not, they're on the rising edge, and they have like a lead time 2 to 5 years. So I think that there are many solutions will come out, and many more people will adapt notebooks beyond data science. So I assume that most of you in the audience here are to some extent data scientists, data analysts, data engineers. I think that you can also help your colleagues who are not into data right now to actually use these notebooks for a variety of other purposes. So if you look on the web, there are many blog posts and articles that actually describe uses beyond data science of notebooks. So this can be actually a core part become a core part of your infrastructure. But this is only being said as a side note. So let me explain what are actually notebooks. So notebooks at the core are active documents. This is not fixed. A notebook contains code, it contains text, it contains visuals, it contains tables. And this mixture gives the functionality together with an explanation and example, everything wrapped up in one coherent story. So this is another thing that's very important for a notebook, or it's kind of a good way of actually writing a notebook. It's having a coherent story, so having one goal, one type of analysis. I want to find one insight. I want to run one experiment. And how the experiment is run and the results, they are documented together. And this makes them very shareable. And this is the way why I said we're learning together. So when I write a notebook, I share this notebook with my colleagues. So everybody can take a look at the notebook, can kind of in their mind go through every step that I made. And because it's active, they can even tweak it. They can change it at certain parts, at certain points to find out, oh, what would happen? What if I change this here and here? What would be the outcome? Would it be the same? Would it be better? Would it be worse? And so on. So it's an important tool for knowledge transfer. It's an important tool for validation. So, oh, is my thought process correct? Did I miss something? Or did I kind of, what's very common in data science, did I overfit? Did I underfit? These typical fallacies. It's good for collaboration because like everybody can share it. And with this type of notebook software that we are using here, we even have online sharing. So when I execute a paragraph, somebody else accessing the same notebook at the same time will also see it executing in parallel. So it helps, it facilitates the integration across users. We have several use cases for notebooks at Sumo Logic. So the first one I want to introduce you is the integration with third-party data. So sometimes you might have some data somewhere else as in Sumo. We acknowledge that, but we also acknowledge that you want to join the Sumo data with the data. So this is like a way of doing that. So for example, if you have a temperature feed, or in the example that I'm about to bring, alerts from PagerDuty, which is kind of this phone call service, you can combine this together using the programmatic ways that Python and Spark and everything else gives you. Sometimes you might want to do something that a Sumo operator itself cannot do, or cannot do it in a way that you want it to do. Or it might be easier for you to do it just in the way of writing a short Python script or something. So you can leverage that to pull out your data and do your analysis or your data extraction other than using Sumo operators. And third, if you're really into data science, you can build and train and test your machine learning pipelines and algorithms using this tool. So the whole machine data, whole machine learning workflow can be broken down in many steps. I personally settle on these 4. Other people might have 7 or 6. you see sometimes. So the first thing that happens is like that you ingest the data. So you kind of, and this is in general, you have the data from some sensors, some feeds, somewhere you pull it together in one place, in one repository, where you can access it. The next step is usually data preparation, and this is kind of where the 80% of the time of the data scientist is said to be spent is in this preparation. It's like in joining stuff, it's like in filling out missing parts, it's kind of cleaning up the data. And then the interesting part comes, like the 20%, where you actually model stuff, where you have, this is the creative part of the process, where you go and you take your ideas, the things that you learn from the textbooks, the models, the formalisms, putting that together, analyzing the data, figuring it out, solving the problem. And at some point, you will hopefully have developed the solution to your problem, and then you're going to deploy it. So the inside the problem that you solved, you make it scale, and this is then the deployment stage. And this is also a very interesting stage when everything has to be integrated with everything else. So the notebooks, of course, can't solve all of these 4 stages. So what typically is solved within this framework of notebooks is this prepare and modeling stage. So for the ingest stage, you can use Sumo. So you have the collectors, you send the data to Sumo. Sumo kind of indexes, prepares it, and kind of prepares the data for usage. And using these notebooks, you can then draw the data out of Sumo, pull it out of Sumo, use whatever kind of steps you need to prepare the data in a way that it can be picked up by the machine learning algorithm. And this is then the third stage, the modeling kind of stuff. And this is also where it ends for now. If we find like more uses and if you help us develop, then we will also maybe get to the deployment stage where you can actually deploy models in Sumo. But this is like maybe next year at the keynote. Okay, so this is like the oversight and the core idea of these notebooks. Here's more, the next 2 slides are more about the technical composition of everything. So this is the tech stack. So Sumo Logic is the platform that delivers the data, and it integrates with Sumo with notebook software and machine learning frameworks. So we have and everything is wrapped together in a Docker container. So the Docker container has the purpose of being one unit of deployment. It has the purpose of making the installation of everything really easy for you, making it really easy. So I've put everything together, I've configured most of the stuff, it's working. Here I also want to point out it's a prototype, it's an experimental thing, so please don't expect it to have the same quality as the Sumo core product, but it will be useful for you. It will help you to get stuff done that you would now have to do using more steps in shorter time. Okay, but focus back on the technology stack. So we got the Sumo core, it's connected through the API, the notebook software, and we have like 2 prototypes here. We have the Apache Zeppelin, and this is what I'm gonna demo, and we also have, like, because of the popularity, the Jupyter notebook. This is also another integration. That's all wrapped up in this single container, together with machine learning libraries like Keras, TensorFlow, Spark, Pandas, and most of the stuff that you would expect to be there. And so after you pull it, and again, this is the link to pull it. Please take the sticker with you and show it to your friends. After you pull it, you can start it. You need the access ID and credentials for it to run, to be able to actually access the data in your system. And yeah, as a result of this operation, you get the data frame. And a data frame is kind of a data structure that's pretty universal, or has become pretty universal in data science. So everybody will work off a data frame at some point. So this is the whole kind of how everything interacts. So the user, everything starts with the user. The user writes the notebook specification. And at the beginning, you start writing the notebook with like defining what is the data that you want to work on, and this is done in a Sumo query. So you write the Sumo query, execute the Sumo query to load the data. This is the pass on top. Then the second pass is the code pass. So you will also have some code. This code will be submitted through the Zeppelin or the Jupiter, and then it will be executed by Spark. So we found that this is like the least common denominator of actually loading and ingesting data, and then the result is the data frame. And then you can use any type of machine learning framework like Pandas or Spark or TensorFlow to actually interpret the data and do whatever kind of machine learning on it. As a result of that operation, you will receive some result like a table or a graph or anything else that makes that helps you understand what your thing does. Yeah, and before we jump actually in the demo, here is like briefly the anatomy of a notebook. This is how it looks like. So typically a notebook software has this kind of controls on the top, and then everything is structured into paragraphs. A paragraph is typically a text field where you can write your code, your queries, whatever, and this is like the input part, and then a paragraph got also the output part where stuff is displayed. So in this example, under number 1, you would enter the code, mostly a fragment of code, then you would execute it and you get immediately a result, which is then displayed as the zeros and ones. Or like in the paragraph to the right, you could also trigger displaying a diagram if you specify. In that case, this is like a clustering diagram where you see like different colors belong to different clusters. All right. Oh, I think now is the... can we please switch to the demo? All right. Okay. Okay, so I've prepared this little notebook for you. I actually want to showcase how to predict PagerDuty alerts from Kafka queue levels. So basically the system is we have a lot of Kafka queues in our system, and they have certain fill levels, and if it goes beyond a fixed threshold, an alarm will fire, somebody will get called and has to react to that. So we want kind of better understand what are the conditions when these triggers are released. And for that purpose, I'm using in general a logistic regression model to kind of fit queue level fillings to PagerDuty alerts. So here in the first part, and this is like the upper part of the paragraph, you see that I specified a standard Sumo query. It's nothing really fancy. It's like I have a source host, and I have like this kind of measure of the queue fill level, which is CQ block locator. It's called like that. I parse it out, I time slice it, so I get like a time series. This is what I want to operate. I want to operate on time series data, and then I average it and group it by time slice to have this time series in the end. So what's special here is like I specify here the Sumo interpreter, and this is like implemented as part of Spark. So it's like we extend this Spark that's deployed with Zeppelin with this Sumo interpreter. And this is how the notebook software understands, oh, this is a Sumo query. I have to go to Sumo, get the data. And as a result of this query, I receive a data frame that has this name that I just randomly selected, my query, and some number. You could write here in this text field any other kind of name that you want to use. So I get this. Here I can select if I want to do logs or metrics queries. And the usual start and end time. So this is how we specify queries in Sumo, having a query, having a start time, having an end time. And as a result of this query, I get back the typical histogram, and please bear with me, I'm a data scientist, I'm not a UI engineer, so I didn't get it really right. It just like gives you the idea of there is data returned, and I have to talk to some of my colleagues there. Okay. So this is kind of the data loading stage. So remember, a notebook usually has this data loading, data preparation, modeling, interpreting of the result stages. So we did the first stage, and this is basically what these notebooks give you. So if I wouldn't have it in that way, and I wanted to do the same, achieve the same result, I typically would need to go to Sumo login, write the query, get the results, then find where the CSV button is, download the CSV, load it in here, etc., etc. So this is like a faster, more convenient way of shortening the gap between Sumo and the actual data science task. Okay, and just to show how the workflow in such a notebook looks like, let me walk you through the other parts of this analysis. So the next thing that I'm doing is data conversion. So please, I don't expect you to read everything and understand the code. Just let me tell you, I'm having like here this Q tabs, and what is it? Oh yeah, it's just some data conversion, some typing stuff. And then the next thing happens here. The next important thing is I have prepared this kind of CSV file. And in this CSV file, all the events from the certain period of time of PagerDuty are saved that are relevant for this time span and that part of the system. Okay, so I end up having another data frame. So I have now two data frames, one with Sumo data, one with PagerDuty data. So, and now the key part comes. I can do a left out. So, and of course the events, the time series I have from Sumo, this will be far longer than the number of events. This is also a very important part for later. So what I actually do now, and this is the important part, I do a left outer join. This means I stick all the events from the PagerDuty, the small number of samples, into the data set with the time series. So more or less the time series gets annotated with alerts. And then I can do some analysis on that. And as I said, of course, there will be fewer alerts. Then there will be like regular samples of the Q depths. So in fact, number-wise, I have like 1,400 samples in my time series, but only 6 alerts, so the data is queued. This will be a key part later on. What this shows here is like I specify the Spark SQL interpreter, and then I can run certain SQL queries just on the data. So this might also be another use case. So if you want to use different types of analysis, you could just specify the query or whatever kind of Sumo query you have, load it into the notebook, and then you can work off SQL. You get it back in the table basically, and then you can work off SQL to facilitate certain queries. So basically, it's all the query language of Spark SQL is available here. Okay, and something. This is a feature that I don't have in the Jupyter notebooks, and this is also part of the reason why I personally like Zeppelin. I can have several languages in the same notebook. So here I make a switch to Python. So I've been using Scala, I've been using Spark SQL, and now here I can use Python. So basically what I'm doing is I'm loading the data, which is kind of in the newer Spark version a very cheap operation. And as a proof of concept, you see here all the data. So you here have this is the time series. Here we have the time stamps, we have the Q depths level, and we have like the alert event. And this is the threshold of 6,000. I know it, so that's why I put it there. But this is also then part of the interpretation later on. Okay, so I've shown you a lot of code and a lot of text and talked a lot. So I think what you really want to see is the picture. So how does it look like? And this is how it looks like when I plot it out. So I hope you're still with me. So the dark blue line is the Q fill level. And then I plotted out some moving averages on top of that to see how it reacts. And the orange lines are the actual alerts. So here you see this is the line. And when the blue line goes over the dark blue line goes over the light blue line, this is actually when an alert gets triggered. Why there's no alert here, I don't know, basically. But here we have an alert, and here, and here, and here. So every of these spikes, of these orange spikes, means somebody got called. Okay, so what can I see here? I can see here, okay, moving average. This is like, doesn't work very well. So basically the decision that I make from here is I work off the raw data. So the typical next thing is to split into training and test data sets. This is what I'm doing here. So I wrote like a function to do that. And the result is here. So I have like in my training data set, I have 5 events, and I have 1 event in my test data set. And this gives me this kind of ratio, which is pretty low. And this will be an important part later on. Here I parse out the events. And okay, so I'm ready to do now my logistic regression as announced. Okay, so I'm just doing logistic regression, and I already see the prediction error and the test error, they are pretty high in comparison. So this is like how how the data set looks like, where the events are, and the green line should be the predictions. But there are no predictions, so it basically, oh, it didn't work on the training data set. This is already really bad. But then I continue to do that, and it doesn't work on the training data set as well, so it's really bad, so it doesn't work at all. So, and this is where this happens quite often in data science. Things don't work. And this is where the part of the communication, the learning together part comes in. So now I can go to my colleagues, I can show them my work, I can show them how I arrived at this faulty result. And maybe somebody got an idea, maybe somebody heard something. And in that case, actually somebody heard something. We are suffering from small sample bias, which is a known fact in statistics. It's like if you have a smaller sample, like sample size of 6 and 1,400 other samples, you can't model the distribution really good. Okay, so you have to find something, and you can do that by including more information. So there are two ways basically. Either can get prior information into it, or I can start weighting the single instances. Both are possible. So, and basically what I wanted to showcase with this discussion now that I led with myself is a discussion that teams should lead among themselves using the notebooks. And okay, somebody found out, okay, I don't know how to do this prior stuff and the other stuff as well. Let's try try it with the hammer. And what I did then in the end, for the sake of the example, I don't say it's good practice, I just repeated the events. So I have 6 events. I just copied them out of the data set and stuck them on the back again. So basically I increased the ratio of events from 0.4% to 13.3%, and I added some randomness in there. So basically I have now more events, so the distribution can be better modeled, it can be better fit. And now I'm trying it again. I'm doing all this logistic regression modeling, predicting, and so on. And ta-da! It actually recognizes the event that it failed to recognize before. And this is kind of a very typical way of how you would model a data science workflow using a notebook. You start with specifying what data you need, you do a cleaning part, you do a modeling part with maybe some failure or some insight during the modeling process, and then you have the result. And the last stage is that you interpret the result. So what to do with this fitted logistic regression model? Basically, this is how it looks like. I haven't shown that before. So these are these numbers. All this effort I did for getting to these 4 numbers. Okay. So what do these numbers mean? What can I do with these numbers? So actually, you can use them to predict kind of alerts. So not with this model, but like if I do it more sophisticated, I could use this kind of numbers to predict future events. So I get a Q level, and then I see, oh, maybe there will be an alert in the next couple of minutes or in the next minute. I also, in my case, I know that the threshold was set to 6,000, I factored that in, but using the model, just using the numbers, I could end up just calculating this 6,000 or getting in the approximate region of 6,000. So that I can find out what is the threshold. And this is actually quite a useful application because there might be some kind of intrinsicalities in systems where implicit thresholds are met, and this type of analysis might be able to reveal them. All right, can we switch back, please? All right, so this is so far the demo. I hope you got the thought process. Don't worry about the details of the logistic regression and everything. Just try to do something that might be useful. Yes, just 2 more minutes for the Oktoberfest. I'm wrapping up. So, what you can actually do, what gives the notebook to you, the immediate benefits that you get from the notebook is like you get this data explorer, you can use the Spark SQL to actually run it down. You got some nice visualization tools. This is part of the Zeppelin tools set. We got some job monitoring. This is like also part of Spark, and you can, through a container, just connect there your web server and then look at this history server. Or if you're using TensorFlow, you can connect and look at the tensor board kind of visualization if you're into that. Oh, not a demo, okay. Sorry, the slides got mixed up. Okay, so thank you very much for being with me so far. In summary, notebooks enable the data science workflow using Sumo data. We enable integrating with other data and experimenting on advanced analytics and machine learning algorithms. We have two kind of notebook softwares available to enable you have the choice of using your favorite tool. We have the standard Jupyter notebooks as well as the Zeppelin notebooks. And it's really no hassle to install it. This is the link. You just need a Docker on your laptop or on your cloud instance installed, and then you can Docker pull our container, and just run it together with the access ID and access key. With that being said, thank you very much for being with me. Thank you very much for your attention. I hope of what we are providing there, and we really would enjoy having your feedback, having your ideas on that, contributing to how we should get this to the next level. Thank you very much.
Thank you. Thanks, Armin.
Thank you.
You know, the one thing interesting is those notebooks have been going on at Sumo for some time, and I've seen interns use them and other people in BI, so
UX
it's not
people.
that hard.
UX people.
UX people as well, yes. So maybe I should do that. Anybody has any questions? Raise your hand and I'll bring the mic.
Are there any plans for other, like using R for example? Are these easily updated for other kernels in Jupyter Notebook or anything along those lines?
Also, there is an R kernel in the Zeppelin. There is an R kernel. I haven't configured it properly, so it might not work. It might work.
Okay.
I just not using R. I gave it like 2 hours or something, and then something went wrong. But basically, it's there.
Okay.
So most of the stuff is there.
Got it. Cool. No, I
So
appreciate
if I know that you want it, then I sit down and make it happen.
I'll check it out probably later this week or something. So now I'm
Cool.
totally interested in this. It's awesome.
Thank you.
Any other questions? All right, download it, try it. Oh, here we go.
Let's say that you're toying around with this, and you get something a notebook that you like. Is it exportable? Can I take it to Databricks?
Oh yeah.
Yeah, right.
Of course, yes. So there is like in the UI, there is. Can we switch, please? So there is in this Zeppelin software, there is this export this node, and it downloads it from the browser on your computer, and this is this kind of JSON format. In Jupyter, I think they have a similar feature. You can also, like if you go into the container, if you log into the container, you can configure the software to connect to GitHub or some other kind of, or S3, and then you can store your notebooks there.
Good question.
Are you planning to be able to deploy this model to Sumo logic and then have it do some action?
I hope so. I hope so, but first I need to convince our CTO and our CEO that is a good idea. Sorry. The question was if we are going to deploy the models that are created, if you are able to deploy them in Sumo. And the answer is I have to convince our CTO and our CEO that that's a good idea.
We'll get there. Once we build more of the platform, we'll get to extension, and then hopefully we get to data analytics model and things like that.
Yeah.
Any other questions? Thank you, Armin.
Thank you very much again.